And now for number 4. Ah, yes. We're going to calculate the R here. Notice we're using millimeters of mercury this time. Liters, millimeters of mercury per mole per Kelvin. In your lab report, everyone except for one of you used atmospheres for R. Uh, um, one of you lab groups used MMHG for R, which is okay, no points off, full credit. It's just most of you used ATM. The lab report asked you to use ATM, but I don't mind if you use millimeters of mercury instead. In this case, you have to use milliliters of mercury because problem says millimeters of mercury. So let's do that. So the R is equal to, well, PV equals nRT. So if you want to solve for R, you divide both sides by NT. Anybody here remember Windows NT? It wasn't all that. So it's R equals PV over NT. Now let's consider the pressure of the gas. We're talking about hydrogen gas here. The pressure of the gas was the same as the pressure in the room, except you had to correct for the vapor pressure of water. Temperature of the water was 19.7. 19.7 is right here. Vapor pressure is 17.2 millimeters of mercury. So the pressure of the gas is this number minus 17.2. So let's do that. Pressure equals this number minus 17.2. So you're going to end up with 739.7 millimeters of mercury. There's a 4, 5 here, but those don't count because this is the last significant figure right there. Do you remember that? Yes, you do. I know you do. All right. So the pressure is 739.7 millimeters of mercury. The volume was 32.99 milliliters, so I'm going to convert that to liters. The N, I'll have to calculate the N. All right, so mass of magnesium was 0.034 grams. So 0.034 grams. Now, if you're going to use the periodic table given in the final exam, that's the mass of magnesium that you'll find there. You know what? In order to find, so this is moles of magnesium. In order to find the moles of hydrogen gas, I need to write a balanced chemical equation. So magnesium plus hydrochloric acid makes hydrogen gas and magnesium chloride. Okay, this is a balanced chemical equation. 1 mole of magnesium gives you 1 mole of hydrogen gas. 1 magnesium, 1 hydrogen gas. So that's it. It's going to be 0.034 over 24.312. 0.034 over 24.312. It's going to be 1, 3. Okay, I can only have 2 significant figures, so it's 1, 4. See, there's only 2 significant figures here, so I'm only allowed 2 significant figures there. The N is 0.0014. And the T is given here. Temperature of the gas, 19.9 degrees Celsius. 19. Oh, snap! Did you write 19.9? Remember, you got to do it this way. You got to put it in Kelvin, right? Put it in Kelvin, okay? So that's going to end up being 293.1 Kelvin, I think. Yes, 200. It's gonna be 0.1 because this 5 causes you to round this number up, So it's 293.05, but this 5 causes this 0 to be rounded up because you're not allowed to have a hundredths place number there. All right, so the theoretical R is 62.4, so the answer should be close to 62.4. Let's see. What was this again? 293. What was the volume again? 0.0239? No, 0.03299. 59. The answer is 59. Oops. The answer is 59 liters, millimeters of mercury, moles, Kelvin. So we go there, and that's the answer. It's 59. See? It says right there. Answer 59. Oh, see, it's supposed to be just be 59, but Canvas puts a 0 there because she doesn't know. She doesn't know how to do sig figs. But the answer is 59.